During the late 19th and mid-20th centuries, wool was one of the world's most valuable agricultural commodities, moving hundreds of millions of pounds of raw fleece from shearing sheds in Australia, New Zealand, the UK, and North America to textile mills required heavy-duty packaging. The woolsack, also known as a wool pack or wool bale. To repair and maintain these heavy woven containers, the Singer Sewing Machine Company produced specialized industrial machines, most notably under the Singer Class 133K series, such as the 133K14 and 133K18. 1. The Singer Sack Darning Machine, Class 133K. Standard sewing machines use feed dogs to pull fabric forward in a straight line at set stitch lengths. However, mending a torn hole or frayed stress point in coarse jute or burlap requires multi-directional stitching. Singer designed its industrial sack darning machines specifically for this purpose. No feed dogs, free motion mechanics. The machine operates without a traditional feeding mechanism. The operator manually moves the heavy canvas or jute sack in any direction, backwards, forwards, sideways, or in circles, to weave a dense grid of reinforcing thread over the damaged area. Heavy needle and thread capacity. Built with reinforced needle bars and heavy-duty tension assemblies, these machines accommodate thick industrial thread and heavy needles, often sized NM 180 to 200 plus, capable of piercing multiple layers of stiff jute or hemp without deflection. High clearance arm and table. The machines feature an extended arm and generous vertical clearance under the presser foot to accommodate bulky, heavy fabric folds without binding. Lifting/spring presser. Foot. Instead of a fixed presser foot pressing down continuously, a spring-loaded or lifting presser holds the thick sack material flat only during the moment the needle enters and leaves the fabric, releasing pressure between stitches so the operator can freely glide the sack. 2. Why wool sacks were worth darning, especially at the corners. Wool sacks were not disposable. They were durable industrial assets designed to be reused across dozens of shipping cycles. Darning the corners was vital for several key reasons. A. High economic value of the sack and cargo. A single wool bale held 300 to 400 plus pounds of high-grade raw fleece. Reusable jute or hemp wool packs were relatively expensive to manufacture. Discarding a pack due to a corner tear was economically wasteful when a few minutes on a Singer darning machine restored its full load-bearing capacity. B. Extreme stress on sack corners, bale ears. The four corners of a rectangular wool sack endure far more mechanical stress than any other part. Manual gripping and hooking. Dock workers, warehouse packers, and shearers routinely grab the corners of the sacks, often twisting them into protruding ears, or driving sharp metal bale hooks into the corners to drag, hoist, and stack 400-pound bales onto carts, trains, and ships. Corner-focused abrasion. When sacks were dragged across concrete dock floors, wooden shearing shed boards, or ship holds, the corners bore the friction. C. Internal pressing pressure. Raw wool was loaded into a mechanical wool press, which used levers or hydraulic rams to compress the loose fleece into dense blocks before the pack was sewn shut. This compression created intense outward hydrostatic-like pressure inside the sack, concentrating force directly into the seams and bottom corners. D. Why darning beats standard sewing? Simply pulling the edges of a tier together with a standard seam creates a high-tension stress line that tears open again under pressure. Darning weaves a new, crisscrossed mesh of heavy thread over and beyond the worn area. This distributes outward expansion stress evenly across the woven jute grid rather than along a single vulnerable seam. E. Preventing contamination and loss. If a corner ruptured in transit, valuable raw fleece spilled out onto dusty decks or transport floors. Dirt, moisture, and road grime entered the bale, ruining the fleece grade. Loosened jute threads from frayed corners could mix into the raw wool fleece, leading to jute contamination, a major defect during the worsted spinning process, because jute fibers do not absorb wool dye. By keeping a Singer Class 133K darning machine on hand in wool grading factories, mills, and sorting plants, operators extended the lifespan of their heavy transport sacks while protecting the valuable wool inside.